Okay, so basically, certain situations, it will be much easier to solve the problem if we can use two equations in two unknowns. So two different variables. If we have two different variables, we have to have two equations. And that's what we're going to do today because we know how to solve those. If it didn't ask for work, you could come up with the equations. You could then graph them, find the point of intersection on the graphs. But these we're going to do algebraically. And this is really where it comes in that you can decide, are you going to use substitution? Are you going to use elimination? And often it's a choice. There's often one variable that is easy to solve for, so that you could use substitution, but sometimes it's not. Remember, if you don't have a single variable, like just an x or just a y, then you probably want to use elimination, what we did yesterday. Okay, so the steps there for a problem: define your variables. So in the written response on your test on Thursday, if it has an application question, you need to, part of your work will be to say, let x be blah, blah, blah. Let y be blah, blah, blah. Okay? And then you write the two equations, then you solve them algebraically, and then you write a sentence or statement for your answer, including any units. Is it centimeters? Is it money? Is it dollar signs? That kind of thing. Okay, so let's take a look here. First one is a rectangle has a length that is 4 centimeters more than twice the width. If the perimeter is 23, algebraically determine the dimensions of the rectangle. So you could even draw a little rectangle here. This is length, this is width. Okay, so I'm going to call it L and W. You could call it X and Y. So I'm going to let L be the length. Let W be the width. Okay, two equations. So sometimes you can tell it's two separate sentences. Sometimes it's not. In this case, it is two separate sentences. So it says a rectangle has a length that is 4 centimeters more than twice its width. So look for the word is. Is basically is an equal sign. So that says L is 4 centimeters more than. What operation is more than? Adding, subtracting, multiplying, or dividing? Adding. Okay, and more than, usually we put it afterwards. So plus 4. And twice the width. Well, twice means 2 times, so 2W. Now in this case, if you put 4 plus 2W, it's going to be the same because it's adding. But if you have less than, then it has to go afterwards, right? In any case, we've got that. Then it says the perimeter is 23. Well, the perimeter, okay, is 23. And the perimeter is made up of 2 L's and 2 W's. Now you could have 2 bracket L plus W, but we'd expand the bracket anyway. Okay, so based on this equation, I've already got one equation that's solved for L. So I'm going to use substitution. Okay, but that's totally up to you. So this I'm going to call equation 1, this equation 2. So I'm going to substitute 1 into 2. So I'm going to have 23 equals 2, bracket for L, and I'm going to substitute 2W plus 4 in for L, right? So now that's the equation you're going to solve. So phones need to be away at the back. Yeah, can you put your phone away, please? Okay, and so expand the brackets and solve for W. select the W's, solve for W's. So that'll be what? That's 15 equals 6W. So I used the diagram, filled up some space there, but W equals 15 over 6, which reduces to what? 3 goes into that 5 times, into 6 twice. Okay. That's W. Now we have to get the length. Well, it's easy to take that and substitute back into equation 1. So length equals 2 times 5 over 2 plus 4. And the 2's divide out there, right? So you get 5 plus 4, which is 9. Okay, so we've got our W value, we've got our L value. Don't have to show it in an ordered pair like we do when it has no context, no application. We have to do the sentence. So that's in replace of an ordered pair. So I'm kind of running out of space. I'm going to go up top here. Okay, and so I often use the word therefore. The length is 9, and look back what units, centimeters. And the width is 5 over 2. You can leave it as an improper fraction. You could show it as 2.5. In this case, it is a terminating decimal, so you could show it as a decimal as well. But I'm just going to leave it as 5 over 2 centimeters. Okay. Right, so that's just basically a perimeter type question. There's sort of different types. You'll see the next one, we have a title for it. It's called an interest question. Interest meaning money. So calculating interest on your money. And so then there's going to be an interest type, a mixture where we get percents with mixtures of items, substances, often it's chemistry like a solution, sometimes it's a mixture of food items, that kind of thing, and then distance, speed, and time. Those are the most common ones. Okay. Okay, so Sam invested a total of $15,000. He put part of it in a term deposit that paid 4% per annum. Who knows what annum means? Yearly, exactly. It's the Greek word for yearly. So that says that you make 4% per year, and the remainder is deposited in a different investment called a treasury bill that pays 5% per annum. After 1 year, the total interest was $690. Algebraically determine the amount that Sam invested at each rate. That last statement often tells you what your unknowns are. So this will be the amount Sam invested at each rate. I'm going to change to blue here. So there's in the term deposit and the treasury bill. So I'll just use X's and Y's. Let X be amount invested in a term deposit. Let Y be amount invested in a treasury bill. doesn't have to be those fancy words. Those are fancy investments, basically. Can be deposited in one account and another account, but they're earning different rates. Okay, so take a look. First sentence is a short one, but that's one of the equations. The total invested is 15,000. Total means equal. Yep. And what does total mean in terms of an operation with X and Y? We multiply them, add them, subtract them, add them. Total means add. When you go to the checkout, they give you the total bill. They've added all the prices together. So that means X plus Y equals 15,000. Don't have to include the dollar sign in your equation. I wouldn't. It gets messy. Include the dollar sign or the unit at the end in your statement. So that's one equation. Then it said he put part of it in a term deposit. So what he put in his term deposit is X, and it paid 4% per annum. Then Y would go in for the 5%, and the total interest was 690. How do you calculate interest? Back to junior high. Okay. If you deposit $100 into an account that earns 4% interest per year, how much interest will you earn? $4. In your account, you'll have 104, but interest is $4. All you do is multiply. Yeah. If it's for 1 year, and this is. If it was for 2 years, then you multiply that by 2, right? So here, we're going to take X and multiply it by the decimal form of that percent. So 0.04X plus, because we're going to get the total interest, 0.05Y, and the interest is 690. So this one got two equations. The first one's pretty nice, right? It's X plus Y. So you could solve for X or solve for Y and substitute it in. The second one has decimals. So if you wanted to use elimination, then you would multiply by what to get rid of those decimals with a nice number? 100. 10 is if it's one decimal place. 100 moves it 2 decimal places. So you could multiply. Maybe this one I'll do elimination. You can use substitution, totally up to you. But if I multiply this by 100, okay, then I'm going to get 4X plus 5Y equals 69,000, right? Because I'm adding 2 zeros to that. Okay, now if I want to use elimination, I need to multiply this one by something to eliminate one of the variables. So I could either multiply by 4 to eliminate X or 5 to eliminate Y. If I multiply by negative, then I can add rather than subtract. So kind of up to you. I'm going to multiply by 4. Okay, so that's going to go here. So that's going to be 4X plus 4Y equals 60,000. To get the X coefficients the same. Okay, so now, because they're the same, I need to subtract the equations to eliminate the X terms. So when I subtract those, the X terms go away. Then 4Y minus 5Y is negative Y. And 60,000 minus 69,000 is negative 9,000. Okay. And so divide by negative 1, you get positive 9,000. If you ended up with a negative value for amount that you invested, doesn't make sense, right? So a lot of these applications, negatives won't make sense for. Okay, so then I will substitute that back into, I'm going to put it back into the equation 1. Okay, and so really that's pretty easy to figure out. You can do it in your head. It'll be 15,000 minus 9,000. Which is 6,000. Okay, then your statement answer. You can, so this is Sam, right? So Sam invested 6,000 in a term deposit and 9,000 in a, sometimes they're called T-bills. So I'm just going to abbreviate with a capital T, bills, because I'm running out of space. Okay. You can always check your answer by substituting the value back in. Let me fix this up here. Both values, I should say. I guess this is just singular. Okay. So 6,000 plus 9,000 is 15,000. That's good. And then you can go back. You can put 6,000 in for X and 9,000 in for Y. Make sure you get 690. Okay. So that's an interest rate question. Kind of relates, it's kind of a little bit similar to a mixture question in that it has percents. Sometimes with the mixture questions, we have to do one more step to set up our two equations. Okay, but this one says a store sells two types of lawn fertilizer. One type is 24% nitrogen and the other type is 12% nitrogen. Determine the amount that is needed from each type in order to obtain 10 kilograms of fertilizer that is 21%. So we're basically taking two mixtures that have the same percentage and combining them, okay, to get something in between. So 24% and 12%, we have to end up with a 21%. Okay, so it's not evenly. If it was, 18, then you just take the same amount of each. Yep, just sign out. Okay, but it's not. So we need to algebraically figure it out. Some of these you might be able to figure out just by guess and check in your head. But if it's in the written response, you have to show your work. Multiple choice, you do it however you want to. Okay, so it says determine the amount that is needed from each type. That tells you what your let statements have to be. So, and the amount in this case, this is a mass, okay? So I might, instead of just saying amount, I might say the mass of each, okay? Let, I'm going to use X and Y again. Let X be the amount of 24% nitro, I'm going to abbreviate with nitro, fertilizer. Okay, it's not 20%, 24% nitrogen. You don't just say that. It's the fertilizer where 24% of it is pure nitrogen. Okay. And then let Y be the amount of 12% nitro fertilizer. Okay, so you've got one bucket here, and then your mixture bucket. And in the mixture, it has to have 10 kilograms. So how much you take out of the first bucket plus how much you take out of the second has to equal 10. That's the easy equation to get. Okay. Oh, I used amount, but then I said mass. In any case, amount or mass, either is fine. Then the next equation, we have to get those mixtures involved. So of that one bucket that's 24% nitrogen, that means 24% of whatever that mass is pure nitrogen. Okay? This one's 12%. And so we have to group it so that we get 21% of our new bucket, which is 10 kilograms. Okay? So that's the part that students forget. So 24% is 0.24 times the amount of fertilizer. That's the amount of pure nitrogen. Add that to 12% of the other bucket. That's pure. And so now the total has to give you 12%, and not just 12%, 12% of the total in that third bucket, which is 10 kilograms. Again, don't put units in. So that is, oh, sorry, 21%. Yeah, I mixed that around. The final needs to be 21%. Thank you. But this 10 is the biggest issue that students make. And if you forget it, then your equations are going to be really weird and they're not going to make sense. So if that happens and they don't really make sense, then probably you missed putting in that final mass of the third bucket that you're making this mixture with. Okay, so now again, last one I did by elimination. Maybe this one I'll do by substitution. So if I do this by substitution, I'm just going to solve this for x. You can solve for y as well. Doesn't matter. Okay. Now if I do that, whether you get rid of the decimals or not is totally up to you. Okay. Probably, for a lot of students, getting rid of the decimals prevents some errors of missing decimal places and that kind of thing. So I'm going to multiply this through by 10. So this one I solve for x. This one I'm multiplying by 10. Oh, not 10, sorry, 100. And so I'll get 24x plus 12y equals. Now, so take a look. I didn't multiply this through, but that is 2.1. I'll do it in green here. So this is 2.1 times 100. Moves the decimal 2 to the right. So that's 210. Okay. Now I'm going to, so this is equation 1. This is equation 2. So I'm going to substitute 1 into my new version of equation 2. You can put it in the original version of equation 2. You'll just have decimals until as you work through. This one I won't. So now I'll have 24 bracket plus 12y equals 210. I'll put the 10 minus y in there. So that's 240 minus 24y plus 12y equals 210. I needed to give you more space here. What's that? So negative 12y equals, what's negative 30, I think? Okay, so y equals, so negative 30 over negative 12. So 6 goes into that, negative 6 goes into that 5 times, into that 2 times. So in this case, because we're dealing with percents, which is basically like a decimal, we can show this as a decimal. Okay, so this is the same as 2.5. Okay, yep, and then the other type is 7.5. Yeah, Seth, as I said, you can probably do some of them in your head, but if it's in written response, you have to be able to show this. If it's in multiple choice, you do it whatever way you want. Okay. So, again, I got to fit this in. So therefore, I'll use the abbreviation for therefore, which is 3 dots in the shape of a triangle. Okay, therefore, we need, or they need, I guess it's a store, we're not doing it. They need 7.5 kilograms of X was 24%. And then they need 2.5 kilograms of 12% nitro fertilizer. So I just kind of fit that in there. I know it's a little bit messy, but I'll say it to you again. So therefore they need 7.5 kilograms of 24% nitro fertilizer. Okay, and 2.5 kilograms of 12%. So that's a mixture question. That's probably the one that students find the hardest, just because they forget that that tenth, that total amount that they're making. Okay. Another common one is distance, speed, and time. Okay, and this you'll find that next year in Math 20, whether you take 20-2 or 20-1, you're going to do some distance, speed, and time questions as well, okay, of varying difficulty. Okay, so this one, just remember from science class, distance is equal to speed times time, or velocity times time, okay? So it took a patrol boat 5 hours to travel 60 kilometers up a river against the current. Okay, so if you've ever been in a river, you go to Bow River, Elbow, you look at it, the current is going one way. So if you are trying to go against the current, it's harder than swimming with the current or being in a boat with the current. With the current, be in your boat and it takes you down. It's not going to take you back up, right? The current is pushing against you when you're going back. So up a river against the current, it took 5 hours and 3 hours for the return trip with the current. find the speed of the boat in still water and the speed of the current. So what it means is if you were just in a pool that had no current, and you were, if this was, let's say, well, it would have to be a big pool with a patrol boat in it. If that was just going along without the current, what's that speed? When you take that and put it in the river, then with the current, you will add on, and against the current, you will subtract the current speed. Okay? So let x be the speed of the boat. Let y be the speed of the current. What you might want to do is set up a little chart. Okay, and what goes in the chart, couple of columns, 3 columns, distance, speed, and time, and for which situation. So just let's wait here. Okay, so distance, speed, and time. So we're going up a river and down a river. So those will be the 2 rows. Whenever you do a distance, speed, and time, it always has basically 4 columns, 3 with distance, speed, time, and then 1 to describe it, and then the 2 situations. Okay, so if you're going up the river 60 kilometers, when you come back down, is that the same distance? Yes. Yeah. Right? You go down and you come back up. The distance doesn't change. So those are both 60. Okay. 5 hours to go up the river. 3 hours to go down the river. Because the current is helping. So if x is the speed of the boat and y is the speed of the current, then going up, remember, it's harder. It's going to be x minus y because the current is working against the boat. But going down the river, the current is helping the boat along. Okay, so we fill in all of the columns there. And then we're going to use that equation, distance equals speed times time, for each row to come up with your 2 equations. So distance, so 60 will equal x minus y times 5. So I might put the 5 out front just because it's a monomial. So here this is going to be 60 equals 5 times x minus y. And this one's going to be 60 equals 3 times x plus y. So we have brackets in those equations. You could expand to get rid of the brackets. What I might do to make the equations even easier is see, does 5, can I divide both of these sides by 5? Does 5 go into 60? Yes. If it goes in, then do that dividing, because then you'll have an equation just in terms of x and y. If it doesn't, then expand it out. So I'm going to divide both sides by 5, and I know 3 goes into both sides there. Actually, I'll go back. So now my equations, 60 divided by 5 is 12. 60 divided by 3 is 20. And look how nice that equation is for elimination. Okay, so if we add those equations, we'll eliminate y. If we subtract them, we eliminate x. Okay, so here I'm going to eliminate y because I like adding better than subtracting, but up to you. You could even, when we've done elimination, we've actually sometimes, well, often, we've eliminated one variable, then use substitution to get the next. If you want to use elimination twice, once for each variable, you're welcome to do that. But this will be 32 equals 2x, because those go away. So x equals 16. So y is 4 when you look at substituting back in. So I'll put it back into equation 2. So 20 equals 16 plus y equals 4. Okay, and unless the boat is very, very slow, well, actually, it wouldn't even happen. If the boat was slower than the current, what would happen? It would go backwards, right? If you're like, I'm a slow swimmer, I'm not very good. So if I'm in a river that has a heavy current, I'm probably going backwards because I can't keep up with the current, right? So I'm going to I'm going to make my statement, sorry. Therefore, okay, so therefore, and you need the units. The boat travels at 16 kilometers per hour, and the current is 4 kilometers per hour. My computer to catch up there. Okay, so we're just going to set up question 5, and you're going to solve it on your own later, because we do need to go through a little bit of the next to summarize the types of systems. So my two situations are a truck and a car. Okay, says how determine the distance the vehicles have traveled when they meet on the highway and how long each vehicle has been traveling. So I'm going to let D be the distance, and let T be the time. Now, in this case, obviously, the time each vehicle has been traveling is different for both. One leaves 1 hour later. So I'm going to let T be the time of the truck. But our final statement will have to list both times. But I don't need two different variables, right? So when they meet here, have they traveled the same distance? Yes, because they're catching up. Yes. So this is D, and this is D. Okay. Now the truck travels at 95, and the car travels at 120. Okay. My let statement was the time of the truck was T. What would the time of the car be when they meet up? T minus 1, because they wait an hour. So the truck goes, okay, the car is not moved. So the amount of time that the car is traveling is 1 hour less than the truck. They're going faster to catch up, right? So this would be T minus 1. So then you would form your equations from each of those. D equals 90t, D equals 120 times t minus 1. Okay, so really this is nice because there's only one term here. So I would use substitution. And they're both solved for D, so I'd probably put 95t into D in the second equation. Expand the brackets, solve for t. Okay, but I'm not going to go through that. You're going to do that on your own. Okay.